we are on slide 23, talking about domain and range. So we are going to define domain and range, and then we are going to learn how to find them. So the domain is the set of input of the independent variable. I'm going to change this. Independent variable. For which a function is defined. So then if we have our range is the set of outputs of the dependent variable. So domain is all your x values, range is all your y values. Okay, what does this in symbol mean on the graph? If you have a point and it's closed, the point is included, right? When we were dealing with inequalities, anytime you had a closed circle, that point or that number was included. Therefore, what would the symbols be if they're included? So we need to insert those symbols. Let's see. I don't think we have Equatio anymore, do we? We can use the scribble tool. I don't really like that though. I'm going to go to insert image from the web. Less than or equal to.
You can go to insert special characters.
Okay. I could do that too. Okay. I think you have, in order to do that, you have to create a text box. So let's create a text box and then go to insert special characters.
Are you good for Sybase?
Hey, yeah, I'm good. When does it start? Okay. So the other one was greater than or equal to. So you got to create a text box in order to do that. I don't like that one. So I'm going to do the same thing. Insert special characters. Less than equal to. There we go. I'm just making some text boxes in here. Okay, so we're on number 4. What does this in symbol mean in a graph? So it's an open circle, so it is not included. So if it's not included, what symbols would be used on the inequality? It would just be less than and greater than. And this one I forgot. We don't have to do the special character. It's actually on our keyboard. I forgot about that. Okay, so for domain and range, we are going to do inequalities to represent what those values are in continuous functions. So what does this mean? This symbol mean whenever it has an arrow at the end, the numbers continue to the left, so they continue toward infinity. In what direction, though? Well, it's one direction. If we just have one arrow, it continues to infinity in one direction. And if it's going left, then it's negative. And if it's going right, it's positive. What about whenever you have two arrows? The numbers continue toward infinity in both directions. Okay, so I'm going to pause it so y'all can get caught up real quick. Okay, so let's look at the domain and range of discrete relations. I'm going to zoom in a little bit. Okay, so discrete means we just have points. We have domain would just be your x values. So let's add a text box here. And it's, no thanks. Okay, so our domain is, I'm going to change this font, is our x value. So we are going to do it with the braces, little squiggly. So we do it from least to greatest, so -3, -2, and 4. Okay. And then our range is going to be -1, 9, and 23. On the discrete functions, when we do our domain and range, we have exact numbers. There's no in-betweens, there's no halves, there's no thirds or anything like that. It's exact numbers. Some of the numbers may be decimals, but it's not like we can do in between. So on number 8, it says the data expressed cost as a function of the number of apples. What is the set that represents the range of this function? So apples, we would have whole apples. Apples are not indivisible. You can't buy a half an apple. You would buy the whole apple. So our range is going to be our y value. So that's your cost. So let's insert. So that would be 20, 40, 60, and 80. Okay, the next one, number 9. What is the range when the domain is 3, 10, 22? So if we're given a function and we're asked for the range given a certain domain, that means we need to use substitution, or we can use the calculator. These are pretty simple that we can do. We can do 3 times 3 minus 4. Yeah. So all we're doing is substitution. So this would be 3 plugged in for this x. So 3 times 3 is 9, minus 4 is 5. And then 10, we'll plug in 10 for x. 3 times 10 is 30, minus 4 is 26. Next one, 3 times 22 is 66, right? Minus 4 would be 62. Number 10, the graph represents y equals x when its domain is -2, -1, 0, 1, and 2. What is the range? So we want the function y equals x. So we want each one of these points. This is a discrete function because it's just points. So let's add some text right here, text box. I'm going to change my font. So when x is -2, what is y? -2 also. Because remember the function, y equals x. So that means that the domain and range are the exact same, y equals x. So our range will be -2, -1, 0, 1, 2. And you could also just look at the points, or you can just think about what the function is, y equals x. Number 11, given the set of ordered pairs, 3, 6, 5, 9, 8, 4, name the set that represents the domain. Domain is what values? X. So we just need our x values from least to greatest. So it'd be 3, 5, and 8. And number 12, they want us to give the domain and the range of this function. So I'm going to let you do that on your own, and then we'll check it. So make 2 text boxes, and don't forget to put braces around them. All right, what's the domain? The x values. So what are the x values? I'm going to go from left to right. So see how we can look at this? We can start left and just look at the x's and see, okay, there's a -4, right? So we'll put -4. And then I'll go -2, 0, then yeah, 3, and then 4. And then the range, you're going to start at the bottom and then go up. So what's the smallest? -4. And then -2. What about that one? We're gonna, yeah, we're gonna say that it's -2. It's just a little messed up there. We don't have to put -2 on there twice. All right, then the next one, +2 and 3. Okay. So for the domain, we're going to follow along the x-axis, going from the negative to the positive, least to greatest. And then for range, we're going to follow the y-axis and go from the bottom and go up. Okay, let's look at the next slide. Let's look at this function. So this is a function that is basically y = x. And the arrows mean it continues on and on. So if I look at the x values, so I know what my domain is, the x values are going to go to -infinity and to +infinity. So the domain here would be all real numbers. And then the range, so look at the y values. So this arrow means it continues on and on forever in the negative direction. And this arrow means it continues on and on in the positive. So following along my y-axis, I know it's going to go from -infinity all the way to +infinity. So that's, again, is all real numbers. So anytime you have arrows going in both directions and you can tell it's going to go to -infinity and also +infinity, then your domain could be all real numbers and your range could be all real numbers. You could have one that is, the range is all real numbers, but the domain isn't. Okay, let's look at 15. So we want to find, let's see, identify the domain. So this open circle, what does that mean? Not included, not in. And then over here, not included. So let's look at the domain. It's our x values. So what does it go from? -7 to 6. And domain is talking about the what values? X values. So we are going to do this as a compound inequality. So -7, I'm going to change that so we can see it a little better. It goes from -7 to +6. So that means x is between -7 and +6. Because they're open circles, we're going to use less than symbols. Because this is continuous, it includes all of the numbers between -7 and +6. We are going to do it as an inequality. And it is the less than symbol because x is between those two numbers, and we're going from least to greatest. So anytime you identify your inequality as going from least to greatest, that's when you'll use the less than symbols. And then it's an open circle, so it's going to not have the or equal to. Okay, let's go to the next one. Identify the range. So range is going on the y-axis. So let's see, how far down does it go? It goes from -4 all the way up to +5. -4 to +5. And dealing with the range, what values are the range? Y values. So we are going to do, the least value is -4. It's an open circle, so it'll be a less than symbol. And this time we're using Y because it's the range. Less than 5.
Wait, and it's less than because it's an open circle.
Yes. And it's also less than because we're going from least to greatest. If it was a closed circle, we'd have the or equal to. But you always use the less than because you're going from least to greatest. Okay, so this is just an introduction to the continuous, domain, and range. Tomorrow we will finish these.